Blaine, maybe you can give us a big picture here, just stepping back. How would you describe the general state of AI and IoT today, and what industries will be most impacted or did by AI on the edge?
Fantastic. So to your question, sort of the state of AI and IoT sort of in relation to edge computing. Yeah, I found it really interesting. I did some research before my presentation at Edge Computing World last week, looking at Google Trends for searches for IoT, machine learning, which is the flavor of AI most commonly applied in IoT industrial type settings, and edge computing. And what I saw was, AI and IoT, or AI, machine learning, and IoT both sort of took off around the same time. 2013, 2014 was when the searches for those terms really began to skyrocket. And edge computing is now showing, or began to show, that exact same trend about 3 to 4 years later. And it startled me when I saw that first, but I don't think that's a coincidence, right? What has happened, and I think most of us who've been in the IoT space know that a lot of IoT POCs and pilots, the initial idea was to push data right up directly into applications running in the cloud, which works perfectly fine if you're running a low scale pilot with a few sensors and a simple application running. But and some of the early work in IoT were those kind of projects. But then once you hit scale, once you hit thousands of sensors, once you hit terabytes of data a day, then then all of a sudden people start searching for edge computing, right? And so there's I call it a 2 or 3 year pilot lag, where you go through the pilot, the learning phase, and then all of a sudden edge computing has started to take off. So I think that we all know IoT has not yet really achieved its objectives, its full promise in many settings, and there's a lot of reasons for that. But one is, I think, the lack of edge computing solutions until recently, and I foresee the same thing sort of happening on the AI machine learning side, right? I think we all know that the central clouds are great for model training, for doing certain things, but if you actually want to run machine learning models to take action in real time for autonomous systems, vehicles, robots, drones, whatever it is, they have to be run on the edge, close to where the data is generated. So thank goodness we now have this edge computing ecosystem being built up, which will enable, I think, AI and ML to move more quickly and not be held back, I believe, like IoT actually was over a lot of the last 5 or 10 years. So, the impact, I think, is going to be huge, because it's going to accelerate both IoT as well as the stuff that's coming on the AI side. A lot of new business models, like John said earlier, autonomous systems, and I'll also get a little plug in there for swarm computing on the edge, because we see a lot of these, again, robots, vehicles, planes, ships, you name it, that are being connected to IoT and automated by ML, are creating ad hoc networks of things on the edge. And we're going to see swarm be a whole other area of innovation, I think, over the next 10 years or so.
Right. Thank you, Blaine. Samy, from your perspective, how can enterprises leverage intelligence, orchestration, distributed architecture at the edge? And how are some of these real-time applications becoming competitive advantages within marketplaces?
Yeah, sure. So real-time is something that comes up a lot about the edge and bandwidth. It's not actually the only reason edge computing needs to be leveraged and used. It comes down to compromise, right? Sometimes it's just the cost of holding data, right? A best example of that is what nature did through Darwinian evolution. Like, we are the most impressive IoT device ever. Like, we have sensors all over our body, and neurons process that data not in the brain but all around, spine, nearby the sensors, and then sometimes it goes to the brain, and then brain makes sense of it. Like, our eyes have special neurons, and images are processed in the eye before getting to the visual part of the brain to be processed. And I think Steve Jurvetson says that edge computing is going to be like a giant sensory neocortex of the world, right? And this is how really people need to look at it. Like, to survive, you need to act upon those, as an enterprise, act upon those constraints. Either it's privacy, so, oh, suddenly you need edge computing to process data right there. Or it's real time, so yeah, you need to process data close. It could be something else too, as well, like cost of hauling data. Like if we have use cases where it's video surveillance of remote sites and AI needs to be run at the edge to process that data instead of being hauled to the cloud to be processed, right? So it all comes down to compromises, and it's just a natural evolution of things that we're moving to edge computing and processing data closer for all those different reasons. And it will be a competitive advantage, if not a necessity, for enterprises to adopt edge computing, not just for IoT, but also for mobile apps. Like how many times I try to access something on LinkedIn app and it's so slow, it doesn't load. It's crazy. That's human. Imagine now machine-to-machine interfaces. Like a second between two machines is forever, right? Cannot happen, right? So, yeah, that's my view on that.
Thanks. Sanjay, so up until now, it's kind of been a cloud-first strategy for many organizations, but what's an edge strategy called? Edge second? But
So that's a great point. I mean, we've gone through essentially the cloud era where we've seen organizations say cloud first, like cloud first. Now, certainly, if you think about what that means for organizations and what they're looking for as applications and systems running in the data centers, running in the plants, on-prem, most organizations, if you talk to CIOs, will say, perhaps, except for manufacturing applications, maybe engineering applications, almost everything has been moved to the cloud. Obviously, keeping in mind any sort of regulatory or security requirements where you can't go to the cloud. And you hear CIOs talk about cloud first, which is saying now there's a value proposition, both from a cost, efficiency, the issue of owning your own data centers and running and managing them and everything else you got to do to keep them up and running. Now that responsibility is gone and shifted to the cloud providers. And the cloud providers have matured so much now. So with the maturity of edge, I mean, you don't know if you want to call it a strategy. We at Siemens, we call it our edge to cloud strategy. So we essentially talk about the processing power at the edge. So for example, we have neural processing units in our PLCs that you can run advanced AI and machine vision and anything that needs compute intensive power right at the PLCs. But we also have edge computing infrastructure that's available for managing that requirements for data intensive, compute intensive requirements that you just can't do in the cloud given the latency and the issues. But at the same time, we also have the cloud approach to say, now I need to look at information at the aggregate level. So at the end of the day, organizations have to say, what is their technology strategy? They have to be flexible to allow for needs on computing at the edge. So not only if you're a manufacturer, you could be in finance or insurance, or you could be a credit card processor. So whatever you're doing, there is always an element of something at the edge. So organizations have to shift from that cloud first and cloud strategy perspective, say now it's more of an edge to cloud strategy.
Thank you, Sanjay. And with that, we're going to move on to our second topic, IoT and Edge challenges and security threats. Blaine, maybe you can start us off. What are some of the key challenges of these innovative technologies that we're discussing?
Yeah, well, let's see. I think at a high level, there's a complexity crisis hitting the edge computing space, right? So to make these systems work, you need, everything from the, the bottom to the top of the stack. You need devices, sensors, actuators. You need communication protocols to make them talk to each other. You need edge hardware to do the computing itself. probably machine learning algorithms, maybe machine learning chips. You need the edge platform to host systems. Then you got to go, all the way up to the actual applications themselves that are running. And, the edge space has many, many vendors in it, including the folks on this call. But the challenge that we have to solve for our customers is largely, how do we help them or bring to them more complete solutions, right? Versus pieces of technology. So solving the complexity crisis, and it's the same thing that has bedeviled IoT in general for the last 10 years and is starting to be solved. I think we now need to solve that much more quickly on the edge. Another barrier I see is use case innovation, I would call it. So, and this again was the case with IoT in the past, I think will be with machine learning. It's what do we do with this? We get this so often when we talk to customers. Okay, this is cool, I get it, we need to be doing this. So what should we do? Like, where should we start? It's helping them think through innovative use cases and applications that are just not just doing what they're doing today a little bit better or a little bit faster. I think maybe the last thing that I see as a key challenge is this issue of disconnected environments. Sanjay talked about this a little bit. In many cases, you do have the ability to run a complete far edge to cloud ecosystem, but in a lot of cases, especially industrial related applications, you don't, right? Like we see, working with hospitals in Europe, by law, they cannot let the IoT device data feeds get outside of the hospital. They have to be processed locally, right? We're working with a Norwegian electrical grid, which again, actually by law, cannot connect to the public internet. They don't want hackers to come in and turn off their electricity. You've got like oil platforms putting off terabytes of data every hour now for scalability reasons. They cannot connect to central clouds, and then tough environments like ships, again, at sea in a storm, you're not connecting. So, to be able to run in either partially connected or fully disconnected environments on the edge, I think is another challenge that some of our solutions are working to address. What I don't see as being as much of a key challenge as it has been in the past are actually things like, scalability, security. And the reason they're not, I know this is a sort of a security focused panel, but it's actually because companies like Hub Security are helping to address the security issues of IoT and edge computing closer to the far edge. So I don't see the inhibitors as really being technology challenges. It's solutions like the folks that on this call are solving a lot of those technology challenges. It's more about overall use case innovation, overall complexity that we need to solve, and a few other things. Great,
thanks, Blaine. Frédéric, over to you. Maybe you can highlight for us how IoT and edge device security challenges are different from those of traditional IT devices.
Yeah, well, traditionally in IT, you're trying to protect your data as it is on the move or on servers, but the edge environment is very, very different, right? You are deploying devices somewhere in the real world where they won't be easily patched or easily accessible, and this brings a whole host of issues that are specific to that environment. But typically, there are four things really that I focus on in that context. First, the fact that an edge or IoT project is always operating on a longer time scale than a typical IT project. You're not talking about a few months, you're talking about years or even decades, because no way I will retrofit all of those locomotives in my fleet every 2 years with new sensors or new boards or things like that. So the time scale is different. Then the second challenge is heterogeneity. There's no one-stop shop in IoT and Edge, in the sense even if you deal with an integrator, they will deal themselves with a host of suppliers, and that's great because IoT and Edge is really an ecosystem, but then you have to deal with that heterogeneity. And sometimes the roadmaps for your various suppliers don't align necessarily, and you have to deal with that and be able to be a bit more hardware agnostic, because you don't want to retrofit the code every time there's a new revision of a board or someone discontinues some critical sensor that you rely on or something. Then the third aspect is certainly the fact that at its core, IoT and Edge is something that's, how would I say that? That's not really So sorry, it seems I'm getting mixed up in my points there. Anyway, the point that I want to make here is really that IoT and Edge has to deal with issues, physical constraints, that you won't have in the cloud environment, in the sense that in the cloud everything is in a secure data center somewhere, and it's climatized properly and all of that. And in the case of Edge, you are literally deploying in the real world. So you have to think about, obviously, ruggedized hardware, but not only ruggedized hardware, you need to ruggedize the software as well, because you have to assume that at some point your hardware components will fail, or maybe you will have anomalous readings and you need to correct for that or something. And the fourth element is essentially the fact that in IoT and Edge, you are dealing with something that's connected, but the network won't be reliable. It will degrade, it will disconnect. And once again, you have to deal with that, but you don't want developers to deal with that directly in their code. You want them to use platforms that will take that in charge for them, and then you can focus on building your use case on the top of that. And to me, all of those four things are really important things that mean that you need to rely on tools and platforms that have been built straight from the ground up for the edge. And not only that, but you don't do pure DevOps at the edge as well, because it's 4:30 p.m. Everyone is on the road. You're not patching your smart road infrastructure at that time, right? So it's a whole different mindset, not just a technology challenge.
Thanks, Frédéric. Gaurav, I wanted to get your thoughts on this as well. You have anything to add to that?
Absolutely. I think what Frédéric just mentioned is the key point. It is a mindset shift that is a bigger challenge from a security perspective, right? The practices that we have seen within the enterprise, such as DevOps, DevSecOps, shift left, apply security at different layers of the entire compute stack, is not a luxury when you start getting out to the edge. So that becomes a challenge. The other piece is organizationally as well. 2 out of 3 IT organizations feel edge computing is a threat to the organization. So there is a huge barrier to adoption as well. So we need a mindset change, a reset, and there is some complexity that we have to address from an edge perspective. So security cannot go layer by layer. We have to think a different approach. So thank you for the shout out, Blaine. Technology-wise, we have the solutions to address, how we can solve the security challenge. The bigger challenge is going to be to get the IT teams and the organizations on board with the change in mindset. So I think that'll be a critical component there.
Thanks. So in short, Sanjay, it sounds like the proliferation of the edge makes it just a major potential attack surface for hackers. Is this true?
Well, this is a point I think really worthwhile to get all the panelists' perspective on. If you remember years ago, I'm sure people do, the Target incident, right? Where did that start? So now when we think about edge and the advances in edge computing, and now what does that mean in terms of attack services, exposure, risk? I'm sure every CISO or security executive wants to make sure that nothing's going to happen. It's not going to be a target one for them again. But the fact is, security practices and security frameworks and software and embedding security in edge devices has matured tremendously. And I'm sure our friends at Hub Security can talk a lot about what they've done in this area. But from my experience, when I've talked to clients, especially even do simple things as IoT, sensors and other elements that make up your IoT network, even if those sensors are talking to the cloud, sensor manufacturers have consciously thought about what is that security model. Speaking about Siemens ourselves, we take security very seriously like everybody else. So There's multi-level security. There's several models out there that are published in terms of how you secure the core, the access to your edge devices, the way data is stored and transmitted, the way you're making sure that your firmware updates are done. So every element has to be taken into account. So I welcome other panelists to chime in on what their thought process is on this topic of security and the edge.
Yeah, I wanted to get to security challenges, solutions in our next topic. Yeah, but if anyone has anything to add on security challenges, feel free to chime in. Otherwise, I think I'll just move on to my next question for Carl. Hey, Carl, how's it going?
Hey, Shterny, thanks. Thanks.
That's for last. What impact do you think edge deployment patterns will have on monitoring and observability tools?
I think it's profound, actually. And I think I'll start with kind of riffing off of what Blaine mentioned before. It is interesting to see users of an orchestration system like ours deploy applications onto a substrate, if you like, where offline nodes is a quite undramatic occurrence. If you're running on thousands or even tens of thousands of places, you know that there will be at least tens of places that are, planned or unplanned offline. So that's not something that is a catastrophic event. That is actually a day-to-day thing. And the impact of that on general tooling, for example, for observability and monitoring, is actually pretty profound. So we see a lot of users, of course, rightly so, trying to reuse their current tooling that are built for, kind of few but complex applications running in a few places, and they try to apply the same thing to smaller applications, let's say 2-3 containers, but running in 2,000 locations. And everything ranging from how that's visualized, what kind of the operations center look like, to how do you declare a deployment successful, if 10 locations fail? And what do you do with those 10 locations? Do you wait until they come up, right? All these things are kind of hard-coded in the, what I call the cloud-centric tooling and the cloud-centric monitoring observability environments. And they kind of fray, if not come apart, when they try to apply that straight up to a more distributed environment. And that also goes to the whole alarm side of things. I mean, it just opens a whole Pandora's box of really interesting challenges of trying to apply, let's call it traditional or centralized monitoring and observability tools to edges, which I think, again, much of the edge conversation, and I'm as guilty as that as anyone else, is about copying computer programs to many locations and starting those computer programs. But that is just the start of a very multi-dimensional experience. Again, trying to keep the operational and developer-centric worldview here. So we think it's extremely exciting to see where this goes. And we love the fact that people are kind of, again, based on their experience with hyperscalers, are pretty well spoiled in terms of ergonomy and in terms of kind of the low friction environment that they've built for themselves. And now they have to kind of take a little bit of a deep breath here to see if they can get to the same kind of comfortable situation, but now running smaller applications on a lot more locations. So I think it's a pretty interesting, and we're just at the start of that journey.
Yeah, and it would be great to hear more. I have a question for Samy. Why are distributed architectures best fit for the edge? And what are some of the operational costs that come along with distributed software that organizations should know about or just keep in mind in general?
Cool. I mean, let me start with a few 100 million years proven system. So every time natures want to do information, DNA, brain, 100 billion neurons, or body, future, like 30, 40 trillion cells, where DNA is there, it's a distributed system. Immune system, when we talk about security in the body, is also a distributed system where white blood cells take their own decision, right? And that's autonomy. It's way beyond what we call in the ops world like automation, where we do declarative things and push that. And then that's kind of like the cloud approach, and it faces disconnectivity, faces different architectures, and it completely blows up at the edge, right? So, distributed architectures means that we want to have nodes being able to process data by themselves, right? And with distributed architecture, especially with Web 3.0, we have also means to secure nodes, to secure data, to secure those devices that Frédéric was talking about that are out there that we have no access to. How do I know that data came from that device? How do I trust that device, right? But also authorization. Does that device need to access a centralized cloudlet or cloud to know what to do? No, I mean, because they might not have communication. So we need to rely on cryptography and basically like blockchain kind of like technology and distributed technology to make really the edge happen. And this is why I believe that distributed architecture is necessary. Now, from the operational side, we really need to move to a more autonomous system. And we had that for a long time, since the internet began, or almost. So what are the things that have been doing edge computing for decades now? Routers, right? Do you input a routing table manually or using YAML files and template systems? No, right? Routers use BGP. They're autonomous, and they're part of autonomous systems. We need to forget about that DevOps approach, declarative approach, and build systems that are autonomous, just like we did for routers and BGP, that makes the internet happen today. And that's my view on this.
Blaine, 60 seconds. Did you want to?
Yeah, I just, Samy, I think you're right on there. And I actually did a series of interviews with a guy named Frode Odegaard, who's at a think tank in Silicon Valley here recently on the decentralization that's going on in societies and businesses, and driven by COVID. Even look at all of us, right? Spread all over the world, not mostly working in central offices. And so the distributed nature of computing is not actually leading that trend, it's following that trend. This decentralization is happening in every element of our society right now on a global basis, government, business, you name it. And distributed computing architectures at the edge are absolutely necessary to enable these transformations, I think.
John, do you see an integrity issue with all product OEMs wanting to send data to their clouds?
Yeah, I was thinking about that when you were talking about security, because we've seen that the integrity question is actually one of the most compelling reasons for many of our customers. Because the fact that you can do the first level of intelligence on the device with no human intervention, and not necessarily sending all the sensitive raw data to the cloud, that actually helps with a number of different issues. And just to give some examples, we have one customer, or actually a customer's customer, said that I don't want the motor provider to know my production rates or how well my production is working or not working, because we're a public company. We're extremely cautious when it comes to data leakage. We had another one who's in the mining industry, and they are very strong in that space, and their customers basically concluded that you can see the rate of which gold is mined around the world, and you could basically predict the gold price looking forward. And then, just like I don't post on Facebook when I'm going away on vacation, I don't want my robotic lawnmower to tell the rest of the world that I'm away and that it's working in different modes. So there are a lot of things where it actually makes sense to push it to the edge. And I think that we are seeing that many customers will not accept that all things connect directly to the cloud and send data. I think that consider who's your customer. if you're a ball bearing provider and you go into a motor, it kind of makes sense that the ball bearing tells the motor what is happening and what's going on. And if the motor is integrated into the machine, then it makes sense that it tells the machine what's going on, because that's your customer, because the customer relationship is actually between the machine and the customer, and they have a contractual agreement. And when it comes to data, contractual agreements are extremely important. It's a very sensitive topic. So it's not, I mean, Edge is not only about communication, it's also about the workflow, and then that really becomes relevant when talking about integrity.
Definitely, great point. Carl, how do you see edge computing impacting the tooling and processes that are used by application teams that are currently working in public clouds?
So actually, John said it, contractual agreements, actually, maybe in other words, abstractions, is a very, very important topic here. And kind of with the background that I have, which is pretty much around data modeling and the modeling languages, you know, I am a kind of a stickler for thinking through the abstractions and representations that form the basis then of the kind of contracts that John are talking about. And what I still don't think we have is a good understanding of what the appropriate abstractions are for the edge in terms of exposing it to people bearing applications that they want to deploy on that. And please note that I'm more of a, you know, my kind of understanding and maybe the expertise kind of stops with the general compute edge, right? So I'm not so much into the firmware edge, but rather where general compute stops. And for that, I think we need to do much better in understanding, again, what are the kind of great and clean abstractions that we need to provide. I think the public cloud crowd has done an amazing job over the last 10 years to come up with how to represent applications and the running state and how to life cycle them and all that. And we're a little behind. Well, we can be forgiven for that. We kind of reinvented this space. We are actually reinventing this space as we speak into some sort of more of a general compute thing. So I think trying to understand, well, first of all, what is reasonably functional and effective abstractions, and then how can we actually make them work with the tools and the kind of processes that are, you know, painfully put in place over the last 10, 15 years around about things like the DevOps virtual cycle and the on and off-prem cloud tooling. And I think it, you know, I'm excited to see the outcome of that. I think it will be less than what people think. I've spent quite a bit of time talking to technology leaders that seems to be turned off the whole idea of bringing their general compute workloads to the edge because they perceive that to be extremely complex and exotic, which I think it actually has a little bit of a sad undertone to it, because I think they're missing out. So it's up to us to prove that it isn't that hard, you know, it isn't as complicated, as prohibitively complex as they perceive it to be. And I think going through a little bit of a thinky phase here around the abstractions and then connecting them to the best practices that are already in place is going to be, you know, the start of the sea change, where we see, again, mainstream application kind of flooding to the edge. And of course, the edge boats will all rise, people, they will all rise. Okay, and actually, now that I got a couple of more seconds. Oh, Shterny, you're back.
Awesome. Yeah, Carl, yeah.
I'll go for it.
Someone was knocking at the door. So for our final topic, I wanted to touch on you know, approaches to the edge and solutions, some of which you guys are involved in. And I also want to remind the audience that when we're done with this final topic, we'll be going into Q&A. So if you have any questions that come up throughout the discussion, you can write them in the Q&A section below, and we'll get to them at the end of this discussion. Gaurav, maybe you can start us off. What can be done to remove some of the hurdles that are traditionally introduced by security measures when it comes to edge computing?
Yeah, there was actually a very funny comment on the chat, which was cloud is someone's computer and edge is anyone's computer. While it's not that simplistic, you know, we gotta think from a security perspective from that perspective. So as Carl was mentioning there, you know, from a cloud perspective, it was easier for us to do contractual agreements. From an on-premise traditional IT perspective, I had immense control where I could apply patches to the operating system to the application, to the data, all these different layers of the compute stack. The challenge with when we start talking about edge and all these new network architectures, it becomes extremely difficult because you lose control and you don't have that same luxury from a contractual agreement perspective. So security that was applied within the enterprise or traditionally with public clouds does not apply well on the edge. So the idea really is that instead of looking at it layer by layer, look at it holistically, and the whole operation is better performed if it is in an end-to-end secure infrastructure. So think about application, from the application to the hardware, the entire stack and the entire compute stack, the entire network stack running within a secure zone. That's the whole concept. We actually adopt that concept. It's called confidential computing. And the idea really is that it's a secure environment within which you operate all the different functions and you put all your critical assets in there. So that's the approach that we believe works really well at the edge.
Thanks for that, Gaurav. And Sanjay, just because of your background and your experience, how would you say large-scale deployments of edge environments are traditionally managed? I mean, of course, it depends on the use case, but maybe you can give us a bit of introduction or background.
Sure. Right. Well, I think if you put things in perspective of what we've discussed today, yeah, certainly the advances in processing power on the edge, the advances in security on the edge, the ability to deploy. I guess there's two things you got to think about. Often we forget, and I run into this all the time with clients, where they forget about scaling, forget about just ongoing updates, or even simple examples like if I have AI models, and let's take a manufacturer, and let's say they got 15 different types of products they're manufacturing. Let's say hypothetically they are pumps, and I've got 15 different models, and I'm going to do some predictive maintenance, a very simple use case. I'm going to deploy it on the edge, on an edge device. Where did the pump? Well, gee, the pump's characteristics are different. I got to train the models. I got to have 15 different models. And let's say I have 10,000 of these deployed across the world. I got to deploy them. Well, what if conditions change and now I learn and I get feedback on how to improve the models? Well, I got to do some retraining, which I'll do probably in the cloud. And then I got to redeploy them. But also I got to think about the fact, the conditions may warrant some other capabilities. So I got to have some tweaks to make. So I think it's very critical as we think about the proliferation of edge computing on the ongoing deployment, management, updates, everything else you got to do, and not forget about that. I mean, we have several options within our organization at Siemens. We have our industrial edge, and a core part of that is the entire industrial edge management system, which does nothing but that. I'm sure there's other capabilities that are available in the market, but that's something I would definitely encourage your audience to not forget, that once you think about scaling and deployment, factor that in both, and the time to deploy and the time to get value. And also once you deploy it, the ability to continuously maintain and manage those edge computing assets and the edge computing capability that you have.
Frédéric, what exactly is Eclipse Foundation doing in the IoT and edge computing space, and how can open source tools like it help mitigate the security challenges that are faced by organizations when managing computing environments?
Well, essentially, our members brought us into that direction, in the sense that for a long time we were just focused on development tools, and then our more industrial members thought it would be a good idea to collaborate on open source components in the IoT and edge space, and that's why we got that started. In fact, we are celebrating this year the 10th anniversary of our IoT working group, for example, so that's certainly an achievement. Now, what we're doing there is quite simple. We have a number of commercial players on this call and overall in the market, right? And what we are doing is essentially we prevent them from reinventing the wheel. In other words, we have a number of building blocks that any organization, but especially commercial organizations, can leverage in order to build IoT and Edge solutions. And the whole point in this is really to foster innovation at the top. You don't want to, well, Linux is a success story because everyone agrees it's a great OS that they can work with. And so we have the same model in IoT and Edge where we try to bring together people with sometimes divergent views on the market or anything like that, but work on things that make sense to mutualize, so to speak. So you spread the risk, you spread the cost, and then you have something that everyone can build on. So that's the approach we are taking with that. And open source is especially important in IoT and Edge because it resolves several of the challenges I alluded before in the call. So the time span, for example, if you're stuck maintaining something for 10, 15 years or more, then obviously when you have the code, it's easier. Heterogeneity, when you have the code, it's easier, etc. And I'm not saying that there isn't a place for commercial platforms or commercial software as a service. Several of our members are doing that, and that's great, but we are enablers for that. And the next frontier, or the next dimension now will be open source hardware. So already there's the RISC-V instruction set as an open source thing in the market, but we have a sister organization, the Open Hardware Group, and essentially what they are doing is open source CPU cores based on RISC-V. So you go on GitHub, you get the design for a specific chip, and you can go to a foundry and do something with that. And in IoT and Edge is especially important, this capacity to tweak the solution to a specific use case, because when you cut the features you don't need, well, essentially you have longer battery life, you have better security and better fit overall for a solution and better flexibility. So all of that we're trying to organize in our ecosystem. And so, well, if you're not already involved with us, anyone on the call is welcome to join. We are an open vendor neutral organization and happy to welcome you.
Great, thanks, Frédéric. Carl, I wanted to ask you, with the idea of having edge clouds spanning countries and even continents, potentially, what kind of approach to placement do you see emerging?
So that's another angle that I find really, really exciting when we see literally administrative domains of computing span, international corporations, meaning that they have maybe retail outlets, maybe open mining locations, other things, literally across continents. So they have the ability to place compute in a wide variety of countries. And to add to that, obviously, not all sites in all countries are the same. So usually a very heterogeneous set of compute, maybe not even owned the same way. Some of these things may be third party or co-located. Some of them may actually be running on one of the hyperscalers, edge compute solutions. And what it comes down to is an angle to application deployment that, again, I think is kind of new to at least to people that are used to working again in the public cloud or public cloud-like environments, which is the issue of placement. And I tend to think about that in terms of almost like criteria-based or filter-based placement. Under which circumstances should a particular application or an application instance be replicated to? Where does this run, right? And of course, criteria can be, as you mentioned in your question, regional. So in which region, in which country can we run this? In which countries, or maybe in which country can't we run this? But it can also be things like, do we want to move these applications across time zones when appropriate? So the whole idea of having a flexible but precise way of explaining to a system, coming back to John's mention of contracts in a formal fashion described to a system under which circumstances an application should run. And we're having a very lively debate, by the way, in the chat field, which is kind of exciting, actually. I tend to think about this also in terms of what the database people would call eventual consistency, taking into account that edge sites come and go, is that you have some sort of intent that you express, under which circumstances you run an application, and the intent will, if you like, be projected on the edge substrate, and it's up to their automation or orchestration system to make sure that we hold true to that intent. So placement, both on geographical terms, but also on many, many other dimensions, I think is another exciting angle to this whole thing that I think also is a little challenging. And I know that I believe we have a lot to do as an industry to see if we can formulate the requirements and what's good about that going forward.
Thank you very much, Carl. Samy, my next question is for you. As we know, with diverse setups, writing code for edge use cases can often get really tricky and complex. Maybe you have some tips on how organizations can alleviate this specific challenge and avoid issues when it comes to scalability.
Yes, so that's exactly what everybody was describing. So diverse hardware, diverse setups, and all of that gets very complex. Like developers are overwhelmed. Like, where do I start? Like, with what I start? How do I deal with this protocol? How do I deal with different IP addresses or changing IP addresses? How do I deal with security? How do I identify my device? All of those needs to be built in. You know, what's done with Linux. You know, when you what's beautiful about Linux is it's out of a box experience. You install Linux on your Raspberry Pi or server, and then it runs your programs. What we need is a platform just like a Linux, but a distributed kind of operating system that has the intelligence to run our functions. Not containers, not whatever, functions, because that what matters. That's the ultimate abstraction that the developer needs to deal with. That's where the business logic goes. And everything else should be provided by a marketplace of third-party modules and plugins that will grow exponentially. Could be AI, could be different IoT protocols, and so on and so forth. And a good example, like what we do at Taubyte, and that goes to distributed systems and peer-to-peer systems, is we can route traffic between two devices without none of them knowing the other's IP address. All they need to know is the ID of the other node, and they can establish communication between themselves. That's how it should work at the edge. Like, imagine a moving car that moves from one cell tower to the other, changing IP address, having the same ID identifying that car and making it so we can communicate with that car wherever the IP address is a huge leap, because developers now don't have to worry about that, right? The system does it for them, right? Same for services. What service a node in the network provides, that's up to the node to decide it in a dynamic way, not for us to declare it in a DevOps YAML file, right? It really needs to be, to Carl's point, kind of like criteria based. Instead of defining like, hey, this is how it needs to be, we need to define those are the criteria that needs to be met to deploy that function or that software at that specific location or that specific node. And circling back to also contracts, like all of that needs to be decentralized too, just like what we're doing with decentralized finance models in the blockchain world with smart contracts. Like for operations, we call that smart ops at Taubyte, and every node decides what needs to be done based on a smart ops contract. Same could be done on, hey, node, do you want to run my compute? It's not really up to who is that computer owner, right? Would that node run my load? Hey, do you agree to run my node? I'll pay you with some tokens, right? And all of that happens on the machine side. Machines decide that. We have to take the human factor out of the equation. We always think, how we should strategize that, how we should operate that, how we should declare that. The edge is so big. There are so many devices, so many servers, so many laws and data centers and owners and all of that. We need to let machines decide that. We need to automate all of that and abstract all of that. And this is the only way that the edge will scale. And this is how we will build a planetary and interplanetary intelligence.
Oh, interplanetary intelligence. I did not see that going there. But I love the leap.
We will.
Great, because sci-fi is trending on my Netflix at the moment. So I'm into it, and I'm open to seeing where the edge leads us in terms of extraterrestrial relationships. And okay, I would like to
actually, Shterny, just to mention, there is a new internet protocol. If you want to Google it, it's called Bendel, and it's about communicating between different interstellar bodies.
Wow.
And it's being developed by one of the internet founders. So it is serious. It is something that we'll get to.
I'm going to check it out.
Not extraterrestrial, just humans expand into the solar system. Just us, humans.
I'm excited. Pushing the frontiers of space. John, I wanted to ask you one question before we wrap up and go into Q&A. What do you see as the true potential of IoT at the end of the day?
True potential, yeah. I mean, starting short-term perspective, as I mentioned before, the fact that we can stay in touch with products through their entire lifespan and actively monitor and manage and maintain them, that is of course a great potential in itself. But beyond that, it almost becomes philosophical. We shared stage with a professor from Sharma University some time ago, Jan Boch, and he said, historically, products have been at their best when leaving the factory, only to deteriorate, and that's not going to be acceptable in the future. And what I meant by that is that we ship generic products that learn out in the field to become better and better and better, and they become customized and individualized. So we're doing mass customization of products, just like we expect when we go shopping in an online store. And that's a pretty interesting concept when you kind of take that further, because it basically means that people will look at you with envy because you get a 20-year-old car. Changing the whole perspective and the idea, because they know that it knows absolutely everything about your driving behavior and preferences and things like that. And that leads into another area. And I just came home from Berlin and the German energy agency's SET conference, so energy transformation. And I honestly think that some of this kind of individualization and customization can make a significant impact on things like just prolonging product life, because you can reduce fatal wear by running every product at its best, but also reduce energy consumption by actually running every product at its best. So an air conditioner will operate differently, of course, in Kuala Lumpur or London, and it should learn that automatically. It doesn't have to be adjusted by a human being. So I think that the potential is huge, but it almost becomes, I'm not going to go into that sci-fi references anymore, but it becomes extremely big and philosophical when you think beyond the immediate implications and features.
Great, thanks, John. And with that, we're going to end our final topic and move into Q&A. Feel free to have more of an open discussion. Less rigid, feel free to interject, to comment, to jump in on one another. I'm going to open up with a very general question. Anyone can feel free to chime in. What do you see? What do you see in the future? What do you see down the line for IoT beyond extraterrestrial communication?
More
planetary. Still humans.
My own prediction is quite simple.
Machines.
We will drop the IoT nomenclature, because essentially it won't be about the internet or anything. It will just be the way of life, right? Connected devices all over the place. And this has deeper implications in the sense that the data aspects that Carl was highlighting, for example, we need to find solutions to interesting problems, like if you have compromised devices, do you quarantine them? Do you mark their data with a little check mark somehow so that you consider that data as doubtful? Or there are plenty of things to explore and fine tune as we'll go forward. And my expectation is that we will solve them, but it will be a bit of trial and error, and we'll see funny things happening from time to time because of that. So it's certainly a great time to be in that segment of the industry, and it will be quite exciting.
And to Frédéric's point, like marking the data, just pointing that because it will be useful for the community. A lot of a lot of people take the regular approach, like, oh, how do I do market, communicate, whatever. I mean, there is something that has been around for a long time, and it's been used at the edge by us at Taubyte, but other companies like Micrometa. It's called CRDTs. And it's a very, very powerful tool to handle use cases like that. It's already figured out, actually. We don't need to figure it out and do the trial error. We just need to adopt CRDTs.
Blaine, I had a question for you, but first I wanted to ask Sanjay, does 5G, when it eventually becomes as pervasive as 4G or NB IoT, mean that the edge will just disappear, it will go away? Will we still have a need for it?
Well, that's an interesting question. I think if you think about why edge has gained momentum, as I'd mentioned earlier, is you need the compute power on the edge. So getting data to the cloud means latency. It depends. I think eventually when 5G is around and that bandwidth and latency issues are solved, you could argue to say, would organizations think about the management, the risks of having compute at the edge? Would that be better served from the cloud? So I think that remains to be seen. I don't think there's a clear answer yet, but I think that's something we got to be aware of, is would that shift take place? And maybe in some cases it will, in some cases it won't. But the other thing also is, would more of a peer-to-peer or a clustering, or I think Blaine mentioned this word swarming, would that become more relevant with the 5G giving you that low latency and high bandwidth capability?
Blaine, maybe you can give us some ideas. There's a question here. What are some key ways to ensure successful deployment of edge environments? Anyone feel free to jump in as well, but I'll start with Blaine.
Sure, thanks, Shterny. And somebody direct messaged me this question, so I think it's a great one. There are a lot of technical answers to that question, and I'm sure many of the folks here could give better answers than I could on that end. But what I see at the higher level is it's about thinking big but starting small, right? Interplanetary system edge is fine, but most organizations got to start with very specific use cases, basic dashboards and alerts based on edge, edge data flows that are processed locally in real time, and then maybe fully automated systems. That might be phase 10. So map out the journey from the beginning to the end, but make sure you have a beginning that's achievable. And again, using these tools and technologies we're talking about here, you can get to value really, really quickly, but make sure you have tools that support this journey, this evolution. Moving to the edge is like having a new baby. It's not a one-time thing. It's just the beginning of something, right? And but get started, I'd say, because making babies is a positive experience. And so get started, get going, but then remember, it's not a one-time thing. And my last bit of advice to folks trying to figure out how to deploy is don't try to reinvent the wheel. I see in the majority of cases today, companies, whether it's CTOs, CIOs, or folks on the OT side, are trying to sort of start from scratch and put these solutions together. And that is the hard way, I'll tell you, because again, using some of the solutions we're seeing, we've got here on this panel, will dramatically accelerate you on your journey toward ROI driving edge computing. So don't start over from zero. Start from a strong foundation that does already exist. Carl, you got your hand up?
Yeah.
Yeah, man. As a good pupil, I raised my hand virtually. I'm just going to pile onto that, Blaine, and thank you for wrestling us back to the surface of the earth and into the edge data center. But I think if there's anything I'd like to ask the panel's membership to agree on with me, is to see if we can do our very best to eradicate the USB stick as the upgrade device and the installation device. I think that's a modest start, and I do understand that there are fringe cases where that may be needed for various reasons, but if we can just get to remove the USB stick out of the deployment loop, I think we're in ship shape over the next year or two.
Should we start a petition?
Yeah, why not?
are absolutely on board with that. We actually design hardware, and that's one of the big requests that comes in. Please don't put it there. So absolutely on board with that.
Excellent. I'll make a T-shirt, Gaurav, and we'll wear that T-shirt with a light.
Absolutely, no USBs.
USB stick, yeah.
And the great news there is that there's a trend already towards that. So we conduct developer surveys and commercial adoption surveys every year. And I don't have the exact numbers in my mind right now, but in the latest commercial adoption survey we did, I think 35 to 40% of respondents told us they do over-the-air connected to the internet updates, and another 30% were doing over-the-air but in a local environment update. So it's heading towards there, but certainly it's not, well, certainly it's a widespread deployment mode, but not necessarily everywhere, and getting to there would be certainly nice.
Carl, in the chat, somebody said, "Are we allowed to use an SD card though? Is an SD card okay?"
I don't know, man. That's stretching.
8-inch floppy.
Only if you're a photographer. That's it. Only if you're a photographer.
Right. There you go.
Just going back to the deployment, I think I'll join Blaine on the high level approach where you need to start small and grow with a little twist to it, because you could start with a hybrid, like what's the name of the Toyota Prius, I think, right? And try to go to electric. But you can also start with a Tesla. Like Tesla was around where Prius was. So you can do the regular thing, but you can also do it in a way that scales, like a Tesla did it. And a Taubyte, we're the Tesla for edge computing. So we're not compromising and going to, oh, let's do like those little steps and making that Prius thingy. But we're really going straight ahead to something that will run on Earth. Like we have clients that are building system with dashboards and processing data online with very, very low code, right? Very, very low code. They don't have to deal with internet, with IoT protocols. They don't have to deal with with containers. They just build their functions. They push their code to GitHub. We compile it. We deploy it. They don't have to deal with any of that. Just like Tesla fixes your Model S remotely without you knowing about that, right? You can still go like the hybrid way, but I think that's not the right way to go, because we need to build something that will scale on Earth. But when I talk about interplanetary, I'm not talking about aliens, though they probably exist scientifically speaking. I'm talking about we having satellites out there. We are going to mine out there. We are going to be an interplanetary species, and we need to be able to expand edge computing. Just go to NASA site, and they're doing edge computing on the Mars rovers. That's edge computing, right? That's interplanetary, right? It's happening on Mars already, and it's happening on Earth. We just need to build the right platforms and have the right approaches that will scale to very large number of data centers and servers and devices. And there are a lot of approaches out there, including ours, including some approaches from the Eclipse group and other people that are bringing approaches to the table. It's just a big ooze where Darwinian evolution will happen, and then the right approach will emerge.
Okay, interesting. And looking forward to that day. I mean, we won't have a planet soon anyways to live on. So yeah, maybe this is a good place to invest in our IoT technology rather than on the climate crisis. With that, I'm going to wrap up because we're just hitting our half-hour mark now. And I wanted to thank everybody for joining us today. Thank you especially to our speakers, Gaurav, Sharma.
Sharma, but yeah, you can call me Sharma.
No, that was a blooper. Sanjay, Kumar, Frédéric, Desbiens, John Linden, Carl Moberg, Samy, Fodil, and Blaine, Mathieu. We hope that you're all staying safe.
Thank you.
And we look forward to hosting many more discussions like these. To get in touch with any of today's panelists, feel free to reach out to them directly. All of today's attendees will be receiving an email in the coming days with the contact information of each of our panelists. So don't be afraid to drop them a line if you have any further questions on anything that we discussed here today. And to stay up to date on upcoming webinars, follow Hub Security on LinkedIn or Twitter. can also check us out on Medium. Thank you everyone for joining. And,
Thank you, everybody.
yeah.
Thank you. Bye-bye.